welcome back to my channel. I am SN Kumendra from SVC. My USN is 1V22CS133. And today's topic is going to be about stacks from data structures and its operations. So let's begin. So first, what is stacks? A stack is a linear data structure in which the insertion of a new element and removal of an existing element takes place at the same end, represented as the top of the stack. These are some basic operations on stack which we are going to learn deeply in the further slides. So first, push. To insert an element into the stack. Pop. To remove an element from the stack. Top. Returns the top element of the stack. Is empty. Returns true if the stack is empty, else false. Overflow. Happens when we try to push more items on the stack that it can hold. Underflow. It happens when we try to pop an item from an empty stack. Next, push. The push operation in a stack involves adding an element to the top of the stack. If the stack is full, then it is said to be an overflow condition. This is a simple program to how to push an element to the stack. First, we are going to initialize push, function push, and then next, we are going to first check if the stack is full or else there is space in the stack. If there is space in the stack, then we are going to increment top of the top element, and then we are going to give the value to the topmost element of the stack. Next, pop. The pop operation in a stack involves removing the element from the top of the stack. The items are popped in reverse order in which they are pushed. If the stack is empty, then it is said to be an underflow condition. This is a simple program to represent how to pop an element from a stack. So here we are going to first check if the stack is empty or not. If the stack is empty, then we return stack underflow. Because if the stack is empty, we cannot pop any elements from the stack. If there is elements in the stack, then we can pop the elements from top to bottom. This is an example to show how push and pop operations work. So when pushing an element into the stack, we go from bottom to top, but when popping an element from the stack, we are going to pop from top to bottom. Display. The display function displays all the elements in the stack. It uses a for loop to do so. If there are no elements in the stack, then stack is empty is printed. This is a simple program how display function works. So if there is no element in the stack, then it displays stack is empty. So first we check the condition if the stack is empty or full, or it has any elements present. If there are any elements present, we use a for loop to get the output from the stack. Is full and is empty. Is full function is used to check whether or not a stack is full. This operation is commonly used before attempting to perform a push operation. Is empty function is used to check whether or not a stack is empty. This operation is typically used before attempting to perform a pop operation. Both the function return boolean value that is true or false. Peek operation. The peek operation, also known as the top operation, retrieves the element at the top of the stack without removing it. So here in if statement we are returning the topmost element from the stack. Overflow and underflow. Overflow occurs when an attempt is made to push an element onto the stack that is already at its maximum capacity. If overflow is not handled properly, it can lead to data corruption or program crashes. Underflow. Underflow occurs when an attempt is made to pop an element from an empty stack. Similar to overflow, if underflow is not handled properly, it can lead to errors or unexpected behavior in a program. It's crucial to check for underflow before attempting to pop an element from the stack. Implementation of stack in data structures. Array. In array implementation, the stack is formed using an array. All the operations are performed using arrays. Linked list. Very new element is inserted as a top element in the linked list implementation. of stacks in data structures. That means every newly inserted element is pointed to the top. Application of stacks. Function calls and recursion. When a function is called, the current state of program is pushed onto the stack. Expression evaluation. Stack data structure is used to evaluate expressions in infix, postfix, and prefix notation. Balanced parenthesis. Stack data structure is used to check if parentheses are balanced or not. Backtracking algorithms. The backtracking algorithms uses stacks to keep track of states of the problem solving processes. Next, advantages and disadvantages of stack. Advantages of stack: easy implementation, fast access time, efficient memory utilization, enables undo and redo operation. Disadvantages of stack: limited capacity, no random access, memory management, stack overflow and underflow. This is a program to demonstrate how push, pop, is full, is empty, and display functions work. So I will be giving the link for this particular program in the description. So let's first see how the program works. So first we define max size of 10, which is the size of array ARR. So next, in top, which is the topmost element, void initialize. We are initializing the top, stack top equals -1. And next is empty. We are checking if the stack is empty or else full. If stack is if the topmost element is equal to -1, then it is empty. If is full, stack of top is equal to max size -1. Where we check if the maximum size -1 is equal to top, then it is full. Here push off operation. We first check if the element is if the stack is full or not. If it is full, stack overflow will be displayed, or the element will be pushed into the topmost part of the stack. Pop function. We check whether the stack is empty or not. If stack is empty, we display stack underflow and return -1. Else, we pop the element which is topmost in the stack. Next, void display. We display the elements in the stack. If we check if the stack is empty or not. If the stack is empty, we display stack is empty. Else, we use a for loop to display all the elements in the stack. This is a main function where we input stack elements or pop stack elements. We use push function to input stack elements. We use pop function to remove elements. And we use display to display the elements. This is a sample output how the stack elements are inputted and outputted. As we have taken all the input values here, push and stack 1 until push and stack 5. So all numbers from 1 to 5 are pushed into the stack. Now the display stack function is triggered. So stack elements 1 to 5 are displayed. And next, when the elements are popped using pop and stack, the elements which are popped are displayed here. Popped element is 5, popped element is 4. So after popping the elements, we display the stack. And the stack elements are 1, 2 and 3. So this is a sample output of this simple program. Thank you all for watching. Do subscribe, like and share the video.